Okay, so we're going to do example 6 now. Slightly more complicated function. We're going to do the same thing though. We need to start by determining the domain of the function f, and then we're going to determine, find the function for the slope and try to find any critical points. In this case, we know the domain of natural log of x is that x has to be greater than 0. And in this case, if we look at the function inside natural log, we have absolute value of x over 1 plus x squared. So just by the fact that we're taking the absolute value, we know that whatever's inside there is never going to be negative. So the only time we have a problem is if x were 0. If x was 0, then we would have 0, and we can't take the natural log of 0. So in this case, the domain of our function is all numbers except x is not allowed to be equal to 0. So we want to keep that in mind, because that's a pretty restrictive domain, and we want to make sure that we don't miss that once we take the derivative. So we're going to take the derivative here. The derivative of the natural log would give us 1 over our function. So we're going to have, in this case, 1 over x over 1 plus x squared. And then we need to take the derivative of the inside, and that's going to be the quotient rule. So we're going to have derivative of the first thing, so that's x times 1 plus x squared minus x times the derivative of the second thing, and that's going to be 2x, all divided by the bottom squared, so that's 1 plus x squared, the quantity squared. So that's the chain rule. First part here was the derivative of the natural log, and the second part was the derivative of the inside function using the quotient rule. So we're going to simplify that now. This big compound fraction here can just flip up as its reciprocal. So we'll have 1 plus x squared over x times 1 plus x squared minus 2x squared. Let's start simplifying some of that. And I can eliminate this and a power, and so now I'm going to have 1 minus x squared. This part here simplifies to 1 minus x squared over x times 1 plus x squared. Okay, so this is our new function. We know that the domain restricts x equals 0, and in this case x can't be equal to 0 either, but that's our only restriction for the domain, so that's fine. We can see that because this term is always going to be positive, so the only thing that could cause division by 0 is this term here, when it's equal to 0. That's already restricted from the domain, so we don't need to worry about it. The next thing we need to worry about is, when is the slope 0? F prime is equal to 0 when the numerator is equal to 0. And that's going to be a common analysis that we look at. We know that this rational expression is only 0 when the numerator is equal to 0. And so we can solve that. We can say 1 minus x squared equals 0, and so x is equal to plus or minus 1. So it looks like we have two critical points that are inside the domain. X equals 1, x equals negative 1. In order to determine whether or not these functions are a max or a min or neither, we can look at the original function and see what's going on, or we could look at it graphically. In this case, this function is complicated enough that you're probably not going to see it on a portion of the test where they expect you to not use your calculator. If we graph that function, we're going to see that it looks like this. Symmetric. And so we actually having trouble drawing it perfectly the same on both sides. But we have a max at positive 1 and negative 1, and they have about this, they do have the same value. And in this case, that's 1 over 1 plus 1 squared, so it's the natural log of 1/2 is the value that they both have. They're located at negative 1 and 1, and the value is natural log of 1/2. If we weren't allowed to use a graphing calculator to determine whether these were a max or a min, we would need to evaluate the natural log at a slightly smaller or a slightly bigger value than the critical point and see if it decreases on both sides. If I have a max, then the value of the function will decrease on both sides. And if I have a min, then if I travel slightly off to the right or slightly off to the left, then the value of the function will increase on both sides. This function it would not be easy to evaluate by hand without a calculator, so it would be not very practical to do so. Later in this chapter, we're going to learn another test that will help us find maxes and mins, or determine whether or not a critical point is a max or a min more efficiently. What I'd like for you guys to do now is to do exploration 1. You guys can work in a group or by yourself. It'd be best if you worked in a group, and follow the same steps that we just did for example 6. So your function is the absolute value of x over x squared plus 1. You're given an interval to look on, and I'd like for you to graphically find the extreme values using your calculator and where they occur. So I want the actual extreme value and where it is. Find the derivative at those values. 2, compare the graph of the function and its derivative. You can graph them both in your calculator and talk qualitatively about how the two graphs are related to each other. And 3, actually take the derivative, find the derivative of the function. You can use your information for 1 and 2 to help you determine maybe how that absolute value plays a role in taking the derivative.